So in this video, we are going to look at recurrence relations. And this is both combinatorics and algebra topic concept. So yeah, and it's very useful in computer science too, so I hope you enjoyed this video. So recurrence relations is basically a relation that describes a sequence where each term depends on the value of its previous terms. So I'll just give you a very famous example, which is the Fibonacci sequence. So in Fibonacci, we know that it goes like 1, 1, 2, 3, 5, 8, and so on. And we can describe this relationship by having the nth term being the sum of its previous two terms. So we say that an, I'll just put that in another color. So an is equal to the sum of its two previous terms, an minus 1 plus an minus 2. So that's how we're going to describe this recurrence relation. But also, we can't just state this. We have to state the base case. So because we don't know what the first two terms will be to get the third term and then to get the fourth term and so on. So in this case, we need two other terms to describe a certain term, which means that we're going to need to state the base values of two terms, the first two terms. So here, we have to state that a1 equals 1 and a2 equals 2. So we get that. So to describe this recurrence relation, we say that we state this relation and then we state the base case. So that's how recurrence relation works. Pretty simple idea. And it doesn't have to be, you don't have to use two terms to describe one term. So if you look at the most simple case, like arithmetic sequences. So some of you might think that recurrence relations have to be some like really complicated formula like this, but arithmetic sequences are recurrence relations too. Because if you look at it, if we have 1, 3, 5, 7, and so on, we have a common difference of 2, obviously. And basically what we're doing is the nth term is equal to the previous term plus 2. Yeah, so it's basically just a recurrence relation, but a really simple one because it only depends on one other term plus a constant. And again, the base case would be a1 equals 1. So yeah, these two count as recurrence relations. And yeah, these are one of the most, is like a really simple case, and this is a very good example of what a recurrence relation is. And now if we look at some more complicated examples. So let's say 1, 3, 7, 13, 21, and so on. Then what we can see is if we look at the common difference, let's again put this in another color. This would be 2. This is the common, a difference, not a common difference. The difference is 2, 4, 6, and 8. And we can see that, yes, the difference is increasing by 2. So we can conclude that, So we can conclude that the difference between any two consecutive terms, so an minus 1, is equal to, or actually, I'll just do an plus 1 minus an is equal to 2n. Because we can see that a2 minus a1 is equal to 2 times 1 and so on. So like we can see an arithmetic sequence here. And we know the formula for these differences is 2 times n. So the difference between two consecutive terms, an plus 1 and an, it will be 2 times n. And if we rearrange it, we get an plus 1 is equal to an plus 2 times n, And yeah, this is a different representation as these kind of things, because here we did an plus 1 and an, and it's like an and an minus 1 here. And yeah, we can just make it the same as them. So basically we just get, or actually, let's just leave it like this. I'll just write that in another color. So an plus 1 is equal to an plus 2 times n. And again, the base case would just be a1 equals 1. So yeah, so we can have recurrence relations like this. So in this case, we had the previous term plus a constant, but in this case, we have the previous term plus a value that depends on n. So yeah, we can have these kind of relationships too. So yeah, this video is just an introduction to recurrence relations and some good examples of what it is. But this is not all. Like, there are very interesting problems related to recurrence relations where you have to find these recurrence relations. And in another video, we're going to look at finding the general term, finding the general formula for a recurrence relation. So in this case, we found the recurrence relation where each term depends on its previous terms. But the general formula is where we describe an in terms of n only. So in that video, we're going to look at how to find the general formula for any recurrence relation. Oh, for certain recurrence relations, because some are very complicated, but yes, I may make a video on that. So yeah, I hope you enjoyed this video, and I hope you and yeah, see you in another video for more examples and content.